Okay, hello everyone, and welcome to the System Dynamic Society's Security, Stability, and Resilience Special Interest Group monthly meetings. This is our first meeting, October 28th. And I apologize if I mispronounce your name, Orkin Ersoy.
Yeah, perfect.
Okay, great. Is going to be talking today, and generally we have an hour, so we'll end it at in 8 a.m. my time. But however you want to use the hour, if you want questions and answers, discussion during your presentation, if you want to wait, whatever is best for you is what we'll do. And we're recording it and up to the iCloud, and I'll work with the society members at headquarters to figure out how to put a link to this on our SIG website. Okay.
Okay, perfect.
Great. And then I will hand it over to you. Thank you.
Okay, hello everyone. Let me share my screen first. Okay, so let me just briefly introduce myself. I'm Orkun. I'm a graduate research assistant at Boğaziçi University in Industrial Engineering Department. And I received my master's degree recently from the same department. And today I will be talking about my master thesis topic. My advisor was Yaman Barlas. I believe he will be joining today in a few minutes. And my thesis topic is the dynamic analysis of false information spread over social media. And I will be talking about 5G COVID-19 conspiracy theory in particular. And I think my presentation will take about an hour. It will take about 20 minutes. And if we have an hour, maybe we can spare the rest of the time for the questions or the discussion, if you have any. If you have any questions during the presentation, you can just raise hand so that I can see you on my screen, and you can ask your question and I can give clarifications. But I believe it's best to leave the questions and discussion at the end of the presentation. So here is an outline of the presentation. I will first start talking about the problem of misinformation in general. Then I will continue with the model description, parameter estimation process for our model, and model validity. Then I will continue with simulation experiments and conclude with conclusions and future work. So now we know an increasing number of people are using social media to gather and disseminate information. And the problem with user-created contents in social media platform is that, as opposed to the traditional media outlets, in social media platforms, the generated content does not go over a fact-checking process, which causes a variety of information deficiencies, such as misinformation, fabricated news, or conspiracy theories. And here are some examples to illustrate the severity of the problem. So Pizzagate is a conspiracy theory about Democrat politicians conducting child trafficking activities under the brand Pizzagate, and it ended up with one person firing a gunshot at one of its stores. And there was a huge dispute about Facebook's involvement in presidential elections in the United States at that time. And also one of many of the current misinformation examples maybe comes from the during the pandemic of COVID-19. We had lots of conspiracy theories and fictitious miracle cures during the pandemic. And one of those conspiracy theories was 5G COVID-19 conspiracy theory. And the theory itself is 5G being one of the causes of COVID-19. So let me, okay. 5G being one of the causes of COVID-19 or increasing its spread. So this debate quickly erupted in the United Kingdom, especially on social media. And although there were a lot of fact-checking organizations and experts falsifying the claims, the misinformation kept spreading resulting in 5G towers being burned down by the believers of this conspiracy theory in the United Kingdom. So let me briefly talk about the literature about the subject. The literature on the misinformation spread is quite huge. Social scientists try to find personality traits that makes people more susceptible to believing or sharing misinformation. Data scientists try to develop detection methods before even it's spread, looking at the content, context, or the propagation patterns of misinformation. Network scientists try to come up with different graph properties, analyze those properties, whether they make those networks more susceptible or more robust to spread of misinformation. There are agent-based simulation models that helps us to analyze different policies and analyze tipping points for specific parameters, and also assess the relationship between the misinformation and opinion dynamics. And finally, there are equation-based models, including the system dynamics models, that helps us to test different mitigation strategies, and sometimes allow us to develop some statistics that help us to differentiate between the true information and false information. There are some policy resistances that inhibit us to attack with problem structurally. For example, as we develop more advanced AI and machine learning technologies to detect misinformation, those same technological improvements also allows the development of more advanced bots that can create such misinformation, or a prevalently used mitigation method, warning labels that are adopted by the current social media platforms often causes an increased traffic for the labeled content, or those warning labels can also create an implied truth effect on the unlabeled content. For example, when you label content, users know that it's false, and if you don't label a content that is not criticized, that is not evaluated, people think that that should be true since it's not labeled. So we have some policy resistances, but before going into the scope of our work, I want to give you a better look on the fundamental research that is being conducted about the misinformation spread. Here we see fundamental theories on human behavior and cognition that thought to be effective on believing or sharing misinformation. And as you can see, there are some individual level effects and there are some social effects. And which subset of these aspects will be effective in believing or sharing disinformation actually depends on which type of misinformation that we are dealing with. So there is a naturally, there is a classification between different types of misinformation, and the fundamental research that is being conducted on misinformation spread usually focuses on one subset, one specific version of the problem, such as conspiracy theories or health-related misinformation or political misinformation. So there is a clear distinction between different types of misinformation while conducting fundamental research. But when we consider the modeling practices that try to, the research tries to model misinformation spread, we see more aggregated version of the models. So here we see an analogy of epidemiological SIR models. So here in this model, S corresponds to susceptible people who do not know about misinformation. Infected people are people who are believing misinformation, and exposed people are the people who are exposed to misinformation. And a different component is defined as Z, which is skeptical users, people who do not believe misinformation. And here we have a more aggregate model. And in this work, authors try to fit the data from various rumors to the same model, and they get a better result in comparison to the traditional SIR models. And the problem with using only one model is that although there are differences between these 4 rumors, the model is not structurally accounts for those differences. And it's not only, it's just one example. There are also other models to account for misinformation spread. They usually have components like fact checkers, protesters, and so on. But these models, usually they are not used for policy intervention analysis. Okay, so they are not used for policy they are not policy informed models. And secondly, they rarely account for the specific misinformation type that they are dealing with. So they do not account for which type of misinformation they are trying to address. So we said that the research is usually focused on one specific domain, thus lacks the holistic perspective, but the policy informing models are few and they overgeneralize without acknowledging the specific drivers of the problem. So we think that there is a need for more complex models that can account for the specific knowledge about the type of misinformation that is being addressed, and still generate policy informed insights so that we can generate interpretability at the scale of systems. But generating one model to account for all types of misinformation is not feasible. So we select one specific kind of problem, and we select that case as 5G COVID-19 conspiracy theory. And we build as dynamic simulation model to analyze the spread of 5G COVID-19 conspiracy. So we aim to identify the causal feedback structure through this model and evaluate different scenarios and effectiveness of potential structural mitigation strategies. So to generate a model, we use system dynamics methodologies since it is easily interpretable and it provides us a testing platform using simulation runs. And as a base model, we use the extended version of SIR models, and we step-by-step implemented some enrichments in the model. So as we come back to more on our specific case, 5G COVID-19 conspiracy, we were mostly interested in short-term dynamics. By short-term, I mean 6 months, around 6 months, because the first rumor, between the first rumor and the attacks on the towers, there are 3 months and so. So we were mostly interested in that interval. We know that at that time, there was a huge dispute in the United Kingdom about the involvement of Huawei in construction of 5G towers. So the topic about 5G construction, 5G towers construction was already polarized between 2 groups. And we know that these 2 groups, there can be, when there are 2 groups opposing, there can be mutually escalation between those 2 groups. One example is provided here, and this graph shows that how pro-mask messages attracted more retweets than anti-mask messages, which resulted in the hashtag no masks gaining traction. So here we see that although the anti-mask tweets get less interaction, since pro-mask messages are sent through the no mask, it caused an escalation between 2 groups. So we want to involve that 2 group, the dynamic between 2 groups involved in our model. And we also know that there are some involvement of financially motivated agents or super spreaders, which allowed us to construct our scenarios after building our simulation model. So here we see the general model structure. The model structure is an enriched version of the original SER models of information diffusion. Here, instead of, usually in terms of misinformation spread, infected means believers, but because of the reasons that I talked about in the previous slide, we wanted to make a disaggregation between believers and disbelievers. So we desegregated those stocks. to observe the opposing dynamics. And another disaggregation is made between the dormant and active users for both believers and disbelievers. So dormant people, dormant stocks means that the people in dormant state, they have an opinion about the subject, they have heard about the conspiracy, they either believe or disbelieve, so they have a stance, but they do not necessarily talk about it and contribute its spread. So believer dormant and disbeliever dormant people, they do not generate corrective information or misinformation, and they do not contribute to the exposure. But active people, on the other hand, they are actively talking about their stance, and they try to generate more awareness about their stance. So they both generate information and they contribute to the exposure. So through misinformation and corrective information, we observe a few reinforcing loops. The first one is the effect of corrective information and misinformation on the believability of misinformation. So based on the balance between misinformation and corrective information on the platform, people's tendency to believe or disbelieve changes, which completes the believer-induced persuasion loop and disbeliever-induced persuasion. And another effect is through the mutual escalation. So the idea is this: as disbeliever dormant people encounter more misinformation on the platform, they tend to stand up for their belief and they start to speak up. So they are more inclined to get activated as they see more misinformation. And a similar pathway is obtained through the corrective information and believer activation. So as they see more correction, they tend to be more identity protective, since the information contains a conspiratorial nature, and they tend to speak up more. So here we have the initial parameterization for the base run. We either use the parameters from the literature, or we use the data from the literature, which is shown in yellow dots, yellow dashed line, and try to get a good fit to the data. So we calibrated the rest of the parameters using this data. And from now on, I will continue with the simulation runs. Let me check time. Okay. So here we have the base case scenario. So in order to differentiate between different runs, we first define 3 outcome of interest, which are exposure percentage, which is the percentage of people that has been exposed to misinformation at the end of the simulation horizon. The total believer peak percentage is the total believer peak of the total believer curve, the maximum level of total believer as in the percentage of the total population. And believer prevalence is the percentage of total population that has become a believer at least once during the simulation horizon. So we define these 3 outcome of interest because we think that targeting different outcome of interest might be more beneficial when we are dealing with specific kinds of information. For example, when we are dealing with misinformation that can cause harm, as it did in our case, we might try to limit the total believer peak. Whereas if we are more concerned about the long-term behavior of people, we might try to limit the believer prevalence. So here in the base case scenario, we have some initial observations. First of all, when we look at this plot, we see that the level of believer actives and disbeliever actives are quite close, although the difference between the dormant levels are quite huge. So we can say that the dominance of believers are overrepresented in digital space in comparison to their dominance in the total population, right? And the second observation is that the susceptible level, all of the susceptible is nearly deployed at the end of the simulation, which tells us, and we can see that from the exposure percentage being 99 as well. So we can say that the spread of misinformation has reached its full potential for the base case scenario. And the first thing that we do was the sensitivity analysis of model behavior for the model parameters. So as we encounter in the traditional SIR model, we have some tipping point behavior for some of the parameters. But interestingly, none of these parameters are related to the disbelievers. So if we were to have a parameter of disbelievers that we can target, it would be a leverage point to develop a mitigation strategy, since it's easier to address disbeliever parameters. But these parameters all are about either believer properties, the believability of misinformation, or the contact fraction, which is about the network property of the total population. So we do not have an easy ticket to target and avoid full-fledged infodemic. Let's continue with scenario analysis. So for the first two scenarios, we have applied the neutral sharing and super spreader scenarios. Neutral sharing means some fraction of the neutral stock also contributes to the misinformation spread. So in the model, except from believers and disbelievers, we have some portion of neutral stock which originally do not contribute any misinformation or corrective information generation. This scenario tests whether their involvement changes the dynamic behavior or not. So when we look at the resulting outcome of interest, we do not see a significant increase for the prevalence percentage, whereas total believer peak changes mildly. So for the base run, we can say that involvement of neutral sharing does not create a significant change. And for the second scenario, we analyze the involvement of super spreaders. So the involvement of super spreader, we applied super spreader for different starting times. So as you can see, involvement of super spreader affects the misinformation increase, a sudden increase in misinformation, and also sudden increase in exposure. And since we observe the exposed peaked around 60 to 80, after 80 we observe almost no change in the exposure, although the involvement of super spreader happens. So when we look at the table, that is represented in the table, in the outcome table as well. After starting time 80, we observe no change in the total believer or prevalence. And similar to the first scenario, we observe little change in the peak percentage, whereas the believer prevalence almost do not change for the base case scenario. So for the first two scenarios, we observe that involvement of neither neutral sharings or super spreaders create a substantial change in the behavior. But the problem with the base case scenario is, in the base analysis, we already told that the misinformation spread reached its full potential. So we wanted to test a scenario where the misinformation is not that strong initially without the intervention of neutral sharers or super spreaders. And from the sensitivity analysis, we know that for the adequate level of believability, the infodemic does not occur. So we wanted to test a base run with low believability. So we decrease the believability of misinformation. And for this case, we observe nearly no peak and 0.1% peak percentage and 1% prevalence, believer prevalence. So we wanted to test whether involvement of neutral engagers or super spreaders would trigger an infodemic for this case. And when we run the analysis, we see that even the 0.5 engagement of neutrals would create an exposure up to 90%. And similarly, a high effect super spreader would create as much exposure as the neutral engagers. and they have some differences between the prevalence percentage and their in terms of their effect on believer prevalence or believer peak. So the super spreaders are as much as effective. They are more effective on believer peak as the increase in misinformation and exposure is higher. But the neutral sharers are somewhat more effective in creating believer prevalence as they are effective for the whole simulation duration. So after analyzing a set of scenarios, we want to investigate some policy interventions. And one of the policy interventions that has been quite mentioned in the literature was decreasing disbeliever activation. So the idea is this: we saw that how involvement of pro-mask people to the hashtag can generate more traction on the subject, right? So the idea is if we can limit somehow the interaction between the disbelievers and believers, we can observe less believers at the end of the simulation. So to do that, we decrease the disbeliever activation fraction. We experimented with different values of disbeliever activation. But here in the comparative table of 3 outcome measures, we do not see a linear pattern for believer prevalence and believer peak. So when we look at the believer peak, we see that decreasing disbeliever activation fraction always results in better results. But considering the prevalence, we observe a nonlinearity here. So first insight is that we have different optimal policies for different outcome of interest. So we need to first define which outcome of interest that we are trying to address. And the second one is, as opposed to linear increase in the disbeliever activation fraction here, the outcome measure of believer prevalence does not change linearly. When we start to increase, we first see worse outcomes in terms of believer prevalence. Then it gets better after a tipping point, which tells us the nonlinear results of the system. So the second policy that we analyzed was the corrective information campaign. So by the corrective information campaign, we increased the corrective information, and we also generated some sort of exposure through the campaign. And linear thinking would suggest that it's better that we run this campaign as early as possible and as long as possible. And our results confirms with the linear thinking as well. But an interesting finding is that, let's say we have a limited duration, limited resource for our capacity, so for our campaign. So if we have 10 days that we can sustain, it's not always better to do the campaign as early as possible. So if we have limited resources for such campaign, it's sometimes better to wait until the misinformation contains its fulfills its full spread. So as there are more exposure about the issue, we should focus our resources to run the campaign at that interval. So this is an insight from the analysis of policy 2. And here we analyze these 2 policy interventions for the 4th scenario that I've talked about. And for decreasing disbeliever activation, we see that sometimes the nonlinearity is contained for these 3 scenarios, but for the lower believability with neutral sharing scenario, we see that decreasing activation fraction up to 0 might provide the best outcome for both believer peak and believer prevalence. But the applicability of such a scenario is controversial, as even if we suggest disbeliever people to not engage with the believers, the chances of that fraction being 0 is quite low. So the applicability of such a policy is still controversial. And for the corrective information campaign, we see that here we see that the comparative table of believer prevalence for low believability and super spreader scenarios. So these are campaign start times, these are campaign duration, and we have the super spreader becoming active at 50. So here we see that the 50 produces better outcomes, the best outcomes in terms of campaign start, which tells us that immediate action after the super spreader is as effective as pre-intervention or post-intervention. So coming up to conclusions, the scenario analysis confirms that neutral sharing as super spreader cases may trigger an infodemic that would not have started otherwise. Policies have different impacts based on selected outcome of interest, and furthermore, linear changes in the policies do not always create unidirectional changes in the outcomes. And proposed backfire effect through the increased interaction of disbelievers with believers is not presented in the scope of our analysis. And overall, our analysis provides insights on trade-offs balanced by different policies, and simulation model allowed us to conduct a causal analysis of such trade-offs. And as a future work, we can further validate our model with richer cross-sectional and dynamic data. We can extend the policies and scenarios that we applied. We can try to apply different user profiles to see the effect of having different users. And one thing that paves the way for such work would be creating other models that can account for other type of misinformation, and try to make analogies and compare these models and compare the effectiveness of different policies for different types of misinformation. So here we generated a model for 5G COVID-19 conspiracy theory, and we made a policy analysis. And to develop such model, we use we utilize different assumptions coming from the type of the misinformation, and we use then a base model. And using the same base model and doing different assumptions, we can come up with different models, and then we can maybe talk about the some structural similarities and differences between different types of misinformation spread. And here are some references. Thank you everyone for listening. Now I will stop sharing, and I can have your questions if you have any.
Well, great, thanks. You have a lot of information there. One thing, not so much a question, is that a year or so ago, I was having discussions with some folks, and right now I cannot remember their names, but they were interested in knowing about me, connected with any people who were modeling disinformation and misinformation. So these were some researchers at Sandia National Labs in the States. So if you'd like, I can dig it out and connect you with those folks.
Yeah, I would like it very much, because I'm currently looking for PhD opportunities. So yeah, it would be great to do some follow-up works.
Okay, I'll grab you. Look, it might not be today, over the weekend, but look, I will. I'll look up those folks and connect you with them.
Yeah, perfect. And do any other participants, do you have any comments or questions?
So one question that I had, and it's it perhaps would be some future work, but at the beginning of your presentation, you started talking about how people would form opinions and all, and within the world of data analytics now, they're doing sentiment analysis and all. Is there a way, or have you thought about how you might use some of the models that are developed in like data analytics and pattern recognition to feed into, I don't know, we're using table functions or straight equations in your model? I guess you didn't get into that, but how are you accounting for the different beliefs and disbeliefs?
Yeah, well, I believe there's a huge opportunity to utilize such knowledge in causal simulation models. Currently, in my model, I use, I believe, 4 table functions, but they were not coming from specific data. They were more like the causal link. We know the direction of the link, so there are some references that there's such a causation, but not sure about the pattern or the magnitude. But well, if the data that I used, for example, was coming from an analysis from 2 years Twitter data. So in order to differentiate between the users that are spreading misinformation, they first gathered data, they did some manual labeling, then they use a machine learning tool to classify the other misinformation as well. So in a sense, there was not a direct relation between their method to our method, but in order for us to use those data, they're still using the sentiment analysis or the machine learning techniques, perceptrons, etc. But I believe we can have, if we were to connect these methodologies, that can be a breakthrough for for this type of research.
And another thing that I found really interesting was when you talked about the differences in magnitude, that the social media, there was a bigger presence of one on social media and others on not. And I wonder how well that would carry over. I would think pretty well to just people who are the active speakers in any type of situation. You know, in the US right now, we have our political parties, and there's the extremes on either parties, and they seem to be the loudest, but most people are really more in the middle, but you don't hear about that. So have you considered how this might carry over into different topic areas of not even misinformation, but different information, and how you may be able to get one person persuaded enough to come over to another belief?
Well, it's much more harder to model the process of one person being persuaded in for an information in the gray zone. So if the information piece, for example, let's say it's political, it's really hard to differentiate between what's true and what's false, and modeling that would be even harder. So actually, since I think it's really hard to talk about that type of persuasion or that type of problem, we specifically select a case where we can differentiate the factual veracity of the information. But I believe in the future we would have to some sort of talk about those points as well.
So that's interesting too. And I with when you broke it up to what was the 2 different cases of believers and non-believers, the dominant and the ones that didn't speak up?
Yeah, had dormant and active.
Dormant and active. And I think you said that sometimes the dormant, when they were presented with other correct information, I think that they remain dormant, but harder still. So that certainly plays into some of the theories of, you know, when people are presented, if they have beliefs and present it with actual facts, they just dig their heels in more. So that certainly plays out with some of the behavioral decision theories that I've heard of.
Yes, it's well, it's these assumptions actually, the assumption of dormant people seeing and opposing information and becoming more active, it actually closely related with the misinformation type that I was dealing with. So for example, a misinformation about, we have lots of other types, and a misinformation about natural disasters. So rescuing efforts during natural disasters, there are lots of misinformation on social media. But when you think about it, when a person encounters a corrective information about their shared beliefs, their shared post, they can easily retreat that post and become believers. Oh, okay, so that video was not correct. I did something wrong. I can just delete it. But for our case, we know that from the qualitative literature, we know that the believers of such conspiracy theories are quite close to other conspiracy theories as well. So, and we know that conspiracy believers often share misinformation not to inform others, but as a person, as an identity signaling mechanism. So for that, it's quite logical to for them to become active as they see corrective action. And they are also opposed to governmental bodies. So any corrective information campaign, they react differently. So that's the interesting part, I believe. Using the same stocks, let's say, we can assume different transactions between the people for different types of misinformation. So some of those types of misinformation, they might be quite similar in terms of the underlying assumptions, although there are different types of misinformation. When we look at the structural properties, they can be similar to each other. Then we can say that, oh, they are similar, and we can use same policies for them. But although looking similar, some of these might be quite different in terms of the assumptions. I believe such an analysis would show those differences and similarities.
Excellent. Well, I don't have any other questions. Does anybody else questions, comments, or? Okay, well, it seems like that's it. So Orkun, thank you so much. As I said, look for an email in the next few days. I'll connect you to with those folks at Sandia. And everyone else, thanks for joining us. We're going to be meeting generally on the fourth Friday of each month at this time. It's in my time zone. I'm on the East Coast in the US, so 7 to 8 a.m., whatever time you guys are in. And if you would like to present or just have a topic you want to discuss, get some feedback in, let me know. We're integrated now. The SIG is website and all of this is integrated with the society headquarters. So you can go on the events calendar and click on the links each month. If you want to present, if you want to volunteer, there's all kinds of links that you can link to, and it'll come to an email that I can see. So I'll get back to you. And Sander, our president, and Asmrit, the vice president, they can access that as well. And even if you don't want to necessarily talk on a topic, if there's a topic that you're interested in to learn about, we can try to reach out and find someone to come and talk to the group. So with that, again, Orkun, thank you.
Thank you for having me.
And I'll end the recording when I come to my recording button again. Okay, I'll end the recording, and I'll let you know. It should be on the cloud. I'm not sure exactly where it is, but I'll let you know how to access it. Okay.
Okay. Thank you very much.
Okay. Well, recording is